Spectroscopy is the study of the way electromagnetic radiation and matter affect each other. Think of the way light is affected when it hits a glass prism. When white light hits the glass prism, it splits into a rainbow of colors. In general, spectroscopy tends to involve breaking electromagnetic radiation, such as light, into component parts, or to be more specific, breaking radiation into individual wavelengths or colors. By doing this, you can figure out how intense the light is in those various wavelengths. The devices we use in spectroscopy are usually called spectrometers. Spectroscopy is important in history because it paved the way for quantum mechanics. It allowed us to better understand electromagnetic radiation like light. Using these observations, we were able to explain blackbody radiation, the photoelectric effect, and the structure of the atom. The ability to understand the intensities of light at different wavelengths has a lot of applications. For example, we can look at the light from the sun, and by analyzing the wavelengths within it, we can figure out what elements are present in the sun. This is possible because of the way hot gases operate. The hot gases contain electrons that absorb the sun's light energy. This causes them to rise into higher orbits. Like an exhausted child, they eventually use up that energy and fall back down to lower orbits. When they do that, the energy is released as light again. However, since it's released equally in every direction, this light has lower intensity as viewed from Earth than it would have if the electrons had never absorbed it. Each element has different possible orbits for its electrons, and so when we look at the spectrum of light from the sun, we see darker areas that match the elements present in the sun. For example, this pattern represents iron. While figuring out the elements present in the sun is an interesting scientific use of spectroscopy, there are more everyday examples of how we use spectroscopy. An example of this would be resonance ionization spectroscopy, or RIS for short. This is a technique that can be used to not only figure out the elements or compounds present in the sample, but to figure out their concentrations. This can be used to analyze medical or chemical samples, to date lunar materials, study groundwater and old ice caps, and prospect for various materials like gold and oil. It can even be used to probe DNA structure and figure out whether a star is rotating one way or another. Spectroscopy is the study of how electromagnetic radiation and matter interacts. We do this by studying the light coming from or shown through a particular material and breaking it down by wavelength or color of light to look for patterns. The light from the sun, for example, contains certain wavelengths that aren't as bright as others. These correspond to electrons jumping between the orbits of atoms in the sun. By looking at the spectrum, we can figure out what elements are present in the sun. Other applications of spectroscopy include analyzing chemical samples, studying ancient water, probing the structure of DNA, and finding natural resources.